TVOT. Here from Comcast. My job the last few years has been deploying EBIF applications across our footprint. This talk is about sharing our learnings from the past few years in terms of development guidelines for app developers. I should ask why at this talk, why at this conference are we talking about deploying EBIF to all these legacy set-tops? Because this is TV of tomorrow, and there's a lot of new technology here about second screens and over-the-top avenues to interactive TV. And so the answer is that we're really filling the gap. I think Comcast is looking at all those technologies along with everyone else. We have 18 million digital subs now that we're trying to supply with valued interactivity. And the only way to get to all those people today is with this EBIF technology, or that's the way we've chosen. And so this is really about TV of tomorrow, as in really tomorrow, not next year or the year after. It's what's available today and how we can bridge the gap until some of these other technologies mature using EBIF. So that's our view on that. So go ahead. So my summary messages. Our EBIF experience from the past few years is we have currently 14.5 million digital subs displaying our home shopping network application, caller ID, and it's a little hard for me to read around the corner. I've never had a curved screen before. And several apps in advertising that sit in 30-second advertisements. An RFI, request for information app, a VOD telescoping app that lets you telescope to the program being advertised, a Ready Remind Record app that lets you set a reminder recording for the program being advertised. So the RFI app, we have one of our own, and we're working with Canoe. I think we have their RFI app deployed across our Motorola footprint on 3 or 4 broadcast channels. Spotlight is our advertising arm, and they're inserting enhanced ads in 40 or 50 networks that they have business deals with for locally inserted ads. Our current work is guide enhancements. We're using EBIF to enhance our guide in an agile manner. We're now trialing an instant info news, weather, sport widget. And we're doing several projects with other programmers for bound applications, and some of them with Canoe. We're moving all of the existing and new apps to our Cisco footprint, another 3.5 million, which is just happening this summer, and to true two-way platforms. In general, Unbound and Spotlight apps we develop internally. Programmer apps, we let the programmer pick who they want. And generally it's with Canoe or sometimes independent. So why in 3 years do we only have 7 or 8 apps deployed and 7 or 8 in the pipeline and not 10,000 app store-wise? So here are some reasons. The EBIF platform is really just new. I think we've shaken out most of the technical issues the last couple years in our first deployments. We have a very mixed platform of Motorola and Cisco set-tops and legacy set-tops with, only the new ones have the big DOCSIS pipeline for out-of-band, so the legacy ones have a small pipe. EBIF has no coding language, so you read the spec, it's sort of like MPEG. It tells the decoder how they decode. There's no language to write applications with, so different developers use different coding languages that are all vendor specific. Probably the biggest reason is the business model is just being shook out. I mean, we have our foot in the water, and we're trying to figure out how to make this into a business. there's a lack of an open SDK that constrains the apps to legal behavior. So there's really there's SDKs out there, different vendors or different developers, communities have SDKs, but if you wanted to output from an SDK a legal app that will run on cable networks okay, then that's what this talk is about. It's about that you can generate problems unless you do things properly. And since we don't have an SDK that constrains the application developer to legal behavior, all we can do is offer guidelines like I'm doing here. And I think Comcast also has a developer's website that has a lot of information, a simulator, and an XDK to, you can write apps itself. Joey. Okay, so I have, the rest of the talk is I have 2 diagrams on our architecture. I'll just go over quickly to sort of set the stage for other things I can talk about. And then I think 6 slides on different topics on guidelines, which are fairly technical, some of them a little detailed. Feel free to interrupt. This is, I want to make this two-way. It would be nice if I learned some go ahead.
What was the telescoping app? I didn't quite understand how that works.
Okay, so the telescoping app is, you're watching a 30-second ad. The ad is for a upcoming programming event. I'm sorry. The ad is for a product, and you're telescoping to a 5-minute VOD asset. It's a long-form advertisement for that product. That's what I mean. Thank you. Okay, so here's, I'll have 2 slides on the architecture. This one is for unbound applications. So we have Caller ID as an unbound app. Our Xfinity remote application where you're on a PC or a tablet and you're interacting with your set-top, with your TV to tune to a channel or to start a VOD. That's an unbound app. Our Instant Info widget, news, weather, sports, is an unbound app. So the basic architecture there, let me go around the curve, is set-tops here, legacy or true to A. Step 1 is you have to get a user agent client on the set-top. It's a Java app here. It's just a legacy process in the OS on this legacy set-top. Those set-tops call home daily to a web server that tell them daily what to do, what they're allowed to run, what apps they're allowed to run. If that information says to run Caller ID or Xfinity Remote, the set-top will do an HTTP GET to download the app from a web server. The app, in the case of something like news, weather, sports, where you need your app has updated to the minute information, the app is going to be talking to third-party sources of information and continually being recompiled and with its freshest data on this web host. So that's the basics of unbound apps is this just HTTP, download apps, download fresh data. You have certain TTLs in the data to tell you how stale it is. We have a database, all our apps log usage in a database for operational tracking and for business analytics. If you do the caller ID use case, a phone call comes into the voice system, and that pushes it through a CMTS to a voice over IP phone. At the same time, the voice system is sending a message to an EBIF app server, or an app server. It's going to instigate an asynchronous message downstream over our RF out-of-band to the set-tops. And this block here is functional unit, which we use across the apps. That's just a generic way of sending set-tops a message asynchronously from server-side initiated messaging, which you can imagine is important for different apps. And so that same service is used in the Xfinity Remote app, where someone's on a tablet and wants to start a VOD or tune their TV, and they send the message up to the high-speed data services layer, and that and the person has tied their tablet to their account and to their set tops previously as a precursor to this use case. And so then the data services server then uses this service to send that set top a message telling it to tune or to start a VOD. So that's the basic unbound application architecture. Bound apps are a little more complicated from the program. Okay, so the bound apps that originate from a programmer have this block here of the programmer complication. And the EBIF.
Can we just like
Go ahead.
unbound and bound apps,
Okay.
little grams?
Okay, thank you. Yeah. So bound apps are in the MPEG, tied like audio and video. It's a data stream that runs like data PIDs that are streaming in the MPEG, synchronized to the video. And that's what it means by bound. And unbound means it's not tied to any programming. Whatever you're watching, you can use the app, sort of like a web app, because it's just going to go HTTP get the app and download it. And so thank you. So the complications of the programmer for the bound app are they need to do just that. They have an app server to generate an application that's tied to their video, relevant to the video. In the home shopping network case, it's every 5 or 10 minutes when the product changes on screen, the server tells the app to change and present information for the new product, so it's synchronized to the video. So that app server is going to go through this compilation phase to generate EBIF. The EBIF is carouseled, which means it's a data resource in the app that's pushed into the MPEG with the video and repeatedly pushed every 2 seconds or every 3 seconds, so that no matter when you tune, you get the latest application. One of the complications is if there are commercial breaks in the app, or if the app only exists in a commercial break. So either you either need to tie it within the ad or outside of the ad. Then you have this complication of integrating the traffic automation system at the programmer with this app server to tell the app to, to exist only in a 30-second break or to stay out of the ad pod. And so that complication, after the programmer output, the app is in the MPEG with the video. We receive it at a national NOC and we rebroadcast all this internally over our fiber network. This allows us to do operational monitoring of it. Goes through local groomers and ad splicers. Another complication, you have to make sure the groomers and ad splicers pass through the EBIF, okay? And to the set top. And other than that, the back end flow is pretty much the same for messaging out. If it's, for example, a poll or trivia app, where your poll results have to go back into the app, a user would use the app, vote on a poll. The HTTP posts would come up to an app server to aggregate them. And either through Canoe or directly to the programmer, we'd send aggregated data back into the programmer, and they would ingest that back into their app. So that's the basic architecture for bound and
Sorry, I just
unbound.
have a question, just the whole the CGS legacy iPhone. Is it possible? So the STP legacy, why out of band? Why can you not route that back to your CMTS also, or can you?
Okay, so in the legacy, that's the legacy versus the true 2A set-tops. We call the channel for communication on the legacy an out-of-band channel because it's a QPSK small bandwidth channel that's has a specific tuner reserved for it in the set-top. In the true 2-way case, it's a DOCSIS channel that has also a separate tuner, separate from your video tuner. Those are the two
So by
channels.
legacy, you mean really legacy?
I mean not DOCSIS.
Okay.
In our case, our only DOCSIS set-tops are true two-way set-tops. That's the difference. So any other questions on those two architecture slides? Thanks, Joe. Okay.
The only part that's real time is on the bottom right, correct? I mean, the apps come in, they don't come in at the instant they're needed. There's, when you put in a compiler, there's obviously that's hours or days in advance.
No, yeah, I would say, like let's take the Home Shopping Network app where the product is changing. So it's a sweater at one point, it's jewelry 5 minutes later. The application logic was created months ago, and it's static. So you can divide the app is divided in EBIF into page and data resources. So part of the app is static, and then there's data resources that are dynamically updated. So it's sort of half and half.
Okay. Where does the static part of that app sit then day to day?
They sit together. It's just they both are parts of the app. They're both carouseled with the video, and they're simply think of it as two different files that are both carouseled.
I'm sorry, when you say carousel, you just mean they're constantly being fed then all the time?
Constantly being fed. Yep. I think we can skip that. This is, you know what, let me just say, it's in the case of bound apps, so it's tied to video, but it's not from a programmer. It's our internal Spotlight, the locally inserted ads at ad splicers. In that case, this whole complication of the programmer is removed, and simply at the ad splicer in each of our ad zones, the splicer vendors now support EBIF, and the SCT 3035 messaging all supports EBIF, and the enhanced ads are inserted there. So it's a large simplification. Other than that, it's the same. Okay, so I think I have 6 slides now on technical guidelines of this is, since we don't have an SDK, this is how we would work with the developer and say, you got to make something that works. Here's the rules. And these are all just exemplary. We don't have to, I won't go into each detail, but it's, my goal was just to show you the type of things and the challenges that app developers need to solve when they develop an app for our cable network. So I had mentioned that we have several different types of set-tops, Cisco and Motorola, and because of the historical purchase of different network or different networks, we have some older set-tops and some newer ones, of course. The way we handle that is because the capabilities of the set-tops are varying. The DCT 2000 is the lowest end of the Motorola capability. We have advanced boxes, true two-way boxes. The way that is handled is we divide them into 3 classes, and the EBIF application can query the class of a set-top and just ask it for its profile. What profile are you in? And the profile of the set-top gives information like this. And so it's device class 1, 2, or 3, 1 being the lowest, like the DCT 2000, 2 being intermediate class, and 3 being the highest class with the best graphics and the most memory, for example. And the type of things that are different on the different boxes are things like a legal application size. So in the smallest boxes here, an app might have to be less than 100 kilobytes on our DCT 2000, on that one box. So if it has to run on that box, then the application developer has to keep the resources within that range. Other boxes on the high end, the app can be a couple of megabytes. Okay. Fonts are limited here, a little more fonts here. Resolution, only these advanced boxes or class 3 boxes have HD type resolution. The challenge is even the native resolution of the SD, native SD resolution of the boxes vary from box to box, so that's a slight challenge. As you go to the higher class boxes, you see that, think graphics, you get improved graphics capabilities like gradients, like JPEG images, or besides simply pelletized pings, you can get full 24 or 32-bit pings on the higher class boxes. Translucency and animation, those functions are added in the higher class boxes. That's, go ahead.
In class 2 and class 3 here, when you talk about animation, when you say limited and supported, can you give an example or two as to what kind of animation?
I mean, it's, taking a graphic, giving it a vector and a speed, and
So
saying, move it, take that, move it from here to here with its speed.
So that would be the limited category.
I'm not sure. I to tell you the truth, what limited and what is
Because
supported?
we built an app a couple of months ago for the class 1, and which the design had a lot of animation built in it, so we basically had to use a workaround to fake the animation. It wasn't animation,
Okay.
it was basically a scaled video object running a video of the animation, and then we go to full screen video. So I mean, in the dev class 3, anything more in terms of animation?
Nothing that comes to my mind. I just don't know it until I'm telling you exactly what the animation is. I've seen it. Go ahead.
Do you have any examples of anyone that's created like one app, but they've developed it for all 3 classes? So there's
Yes,
like
the next slide,
Okay.
I'll do that. Good question. Thank you. Any others? Good. So here are some guidelines that help us manage all those different capabilities on the different boxes. And these are just, again, exemplary. So what's the first point is that app page or data resources may need to vary across the boxes. For unbound apps, that's pretty easy, because in the unbound app case, remember the set-top does HTTP to download its app, and we tell it the URL to go get it. So, and we know the set-top, so we can tell all the D2Ks to go get app version A and all the advanced boxes to go get app version B with has a lot more functionality built into it. So it's very easy. In the bound case, it's a little trickier because you have home shopping network, you only have one video, and the question is, do you want to duplicate resources and spin? So that's one option. You could duplicate resources and send a high-end version and a low-end version. But then there's bandwidth issues, potentially. There might not be. One thing that generally is done, though, is frequently you'll see in the apps where they'll have logic in the same app, only one app. It'll ask the set-top. If you are type X, then the app logic will be to do certain things, and if it's type Y, do something slightly different. And has to do with lots of things we showed, like the graphics.
But you couldn't, it's almost like mobile detect. You can't go and say, send out sort of a detect, say, okay, this box is, 1, so send the app, go get the app, app for 1, or this box is 2, and then you go and you get that app, so it's not like.
No, you can't. In the unbound app, in the unbound case.
I'm not about bound. I work.
In the bound case.
Yeah, I work for HSN. So I'm
Okay.
just trying to figure this out myself. Yeah.
Thank you for letting me use your app for
Sure.
my examples. In the bound case, you can, if you want to do that, you have to spin in the carousel different resources for each of the set-tops, and then you can, you can direct each of the resources to only be read by certain set-tops. So you would essentially do what you said. So an important case, the one case that generally is done is the simple case that the class 1 boxes can only do 4-bit pings, and the other boxes can do 8-bit pings or full or pelletized pings or full 32-bit pings if they so desire. So to get better images, for example, logos of advertisers or something on the high-end boxes, generally the apps do have logic that query the set-top profile and say, if you're a low-end box, use this image, else use this. So, and the app will spin two pings in it, two versions of the ping. So if this would be another example, if you want to prevent the app from, if you only want to code it to show on a high-end box and just not even offer it on the low-end box, then that's doable. You can tell the app using this EBIF platform targeting methodology, you can target the app to just be ignored by certain classes of set-tops. So that's one other option. And then the coding, the resolution issue is that the different set-tops have different native resolutions. Like even in the SD, it's 640 by 480 or 704 or 720. And so you have to solve that if you're going to run on all of them. So there are really two options. You either can code at 640, and that will work unless you have a full screen image. If you have a full screen image and you code it at 640 and run it on a 720 box, you get little video bars left and right. So if that's acceptable, you can do that. The other option is if you want to solve that, is you could code at the biggest resolution, 720, and just allow for the fact that on the 640 boxes, you'll clip a little left and right. So you just treat that as a safe area. So that's generally a fairly easy way to manage that. Okay, so I think the next two slides are about bound apps. So what are some complications and what are some guidelines with the bound apps? So the first is bandwidth, is that if you want to bind an app to the broadcast video, you're going to consume bandwidth. So right now the MPEG channel has audio and video in it. And so what we have planned for is that on average, that the apps will be allowed about 200 kilobits a second. And we did that by managing our own internal encoding. When we receive video from programmers, we re-encode it to we get it at a very high bit rate, put it out an SD version. We combine it with 12 or so other programs in a multiplex. And we've allocated bandwidth for that. But that's sort of the target. That would be an average. It's not a strict rule. That shows you the size, capabilities. PMTs. This gets into a little bit of the MPEG. The service you're on has to spin a PMT that declares the EBIF PIDs in it 24/7. Even if unlike HSN, if you're on a service that is only displaying a 30-second ad once a day, that programmer needs to broadcast to Comcast a PMT that declares their EBIF PIDs in their PMT 24/7. It's a small complication, or it's easily done, not really a limitation. And then, if a programmer is broadcasting an app and it's not going to all their service providers, maybe it's going to Comcast or to Time Warner, but not to other service providers, then generally the way we handle that is they use a virtual PMT. They use the same, everyone gets the same video, but the PMT is encrypted differently with the app. Excuse me. And that the different encryption of the different PMTs will constrain the application to certain service providers. So that's So then this bottom issue is how to synchronize, so that synchronize into or out of ad breaks. So this is something that Canoe has helped with a lot, because they've been working with programmers and they have a good bit of experience educating programmers about how exactly and how best to do this. The basic idea is that we have to integrate with the traffic automation system to tell the app when to come up or down. And the rules of the road here are that let's take a case of an app that has to be shut down during ad breaks. It's maybe a polling app, and it's in an hour-long program, but during ad breaks, the programmer wants to remove it so it doesn't display over their advertisers. The rules are that if you drop the EBIF data PIDs, the user agents, according to the spec, will display the app for 4 seconds. So the traffic automation system needs about a 4 or 5 second leadway on when an advertisement is coming up. So that's sort of what the EBIF spec allows for. So what we have done in the past is we've had programmers both drop data PIDs and turn them back on after the ad pod with that 5 second window limit, and also send a trigger to the app to tell it to suspend and resume, just to beat the 4 second limitation and tell it to shut down immediately. So it's a
This is
guideline.
not bound stream, right? You're talking about bound apps.
These are
So
bound.
how do you, if it's already bound, how do you, insert triggers?
So remember, the bound app is the one that's data PIDs along with audio and video. So it sort of looks like audio, about the same size as audio.
Yeah.
And triggers are simply little data elements in the app that are synchronized to something, and so they're sent as part of the carousel. And you would tell the carousel, if say the data in the app is being repeated every 3 seconds,
Yeah.
you might, at some point, you tell it, hey, now start sending a trigger. And you might only do that for 10 seconds, and then you might tell it turn off the trigger. So that's,
Okay, so it's not actually it's not a stream that's already been made and the trigger's already there.
no.
It's actually the so you are actually controlling the carousel.
There is,
The
yeah.
delivery system. Okay.
Go back to the architecture diagram, about 4 back. You can look at that. This one. Yeah, this is a good one. So the apps aren't they're not static. Remember, in the case of home shopping, it changes every 5 minutes. So, and for other reasons, like this, the app reacts instantaneously to lots of things, like traffic automation, like poll results that come back in. So this duo of the programmer and this compiler are dynamic. They respond within a second, roughly. Okay, so that's it on that. Go ahead and do the next one. Okay, so more bound app. A couple other guidelines for bound apps. Handling DVR and time-shifted behavior is a subtle issue. So you first need to think through, do you want the app to run in DVR mode? Does it make sense for someone to see this app a month after it was recorded? And same thing with time-shifted. The default in the EBIF spec is that if you do nothing, it will run in DVR mode. And in time-shifted mode. If you want it to run in DVR mode, but only for a week or a month, but not 5 months, one option we've done is build a logic in the app to just ask the set-top the current date and say, don't run after this date. If you don't want it to run at all in DVR time-shifted mode, which is some of the development we've done has been in that, we've had that business requirement, then the way to do it is technically to look at these environment variables that are in the EBIF spec, depending on whether the user agent you're running on is what version of the spec it supports. But it's easily doable, and so you can look at that environment variable, and that variable tells you the mode of viewing. Is it live? Is it DVR? Is it time shifted? Or is it VOD? And you base in the app. When the app is moved into the running state, when it first wakes up, it says, what's my mode of viewing? And if it doesn't want to run in DVR time shifted mode, it looks at that environment variable, and if it sees a mode it doesn't want, it just shoots itself in the head. Handling channel changes. So a user agent will suspend an app, according to the spec, within 4 seconds without EBIF EISS signaling. That's EBIF signaling. So if you channel change, if you did nothing else, the app could at least continue running because the guide probably came up when you channel change. That will suspend it, but the app would run. Under the hood, it would still run. So that, and we've come across an interesting use case here, is if for example, an RFI app is running on a bunch of different networks, and like our Spotlight apps, our internal ones, are running on 40 or 50 networks. And you might have a Coke commercial on one network and a Pepsi commercial on another. And you don't want the user to tune to the Pepsi commercial and get the Coke overlay. So because of that use case, we've created this guideline we've required for all our programming partners that on a channel change, the app terminate itself. Because if it didn't, there could be, if you're tuning from one app version to another, if you didn't terminate, it could use data resources from the old channels that were never. That's the type of complication, another one you might get with the bound app.
You want to ask a short question?
Yeah.
Originally, in this spec, we talked about the 4 seconds because of the concept that you might, you might tune away for a second, check the score on your game, and then come back to where you were.
Really? Is that how they came
You
out?
wanted this little window of a couple seconds where if you did tune away and then you came back, you could then gain context. But are you saying that actually your guidelines are just kill the app because you're safer in the long run?
That's really it is. It's a safety thing, and it's
Okay.
really because of that one corner case.
Okay.
It seems, yeah, and I think in the end it's sort of cleaner in terms of life cycle management.
Certainly.
Yeah. The canoe rule with the bound apps. So I had mentioned before, for program apps, Canoe helps solve some of this. This is their business, to ease the pain for programmers, to enable programmers to do this easily. They know this better than me, and all the implications back at the programmer. They can help onboard and help the programmers with that. In the Canoe case, at least for now, we're using the full CableLabs SAFI specs. SAFI is stewardship and fulfillment interfaces. It's an advanced advertising spec that CableLabs put out. There's 4 different specs with related to that, and it really is a way to formally enable stewardship, to really track advertisement and to track it for the monetary business purposes that you need to. So that would be another issue. Go ahead. Any other questions on the bound apps, guidelines, complications? Go ahead.
Does that apply then that, because you're putting so much of the effort on the programmer here, you guys must have crazy 100-page business deals with these guys, is that
I mean, I honestly,
maybe you don't know, yeah.
I don't really know. I mean, I know it's,
Okay, 80 pages, okay.
yeah, you would know.
About 80 pages.
80 pages,
Not 100.
okay.
They're pretty-
I was just curious.
I think that I think part of the thing there, like you could say, is the programmer and the MSO need to agree on, if something fails, how to handle it. So I mean, part of at the engineering level where I review things, it's what's the role of both parties on an app failure? How, is there a guaranteed delivery, or is it best effort or things like that?
No.
I think for now, I think best effort is probably what we've been doing because of the young nature of our platform.
Yeah, and a lot of it is, it's an addendum to an 80-page agreement that we have just to carry our channel. So
There's a lot of good faith stuff.
this type of, ITV or just, launching high definition are just things that we add to existing agreements that were established like 20 years ago. You know what I mean?
Thanks. Okay, these here's just a few points about two-way messaging. We've standardized on just a CableLabs spec for this. This SAFI IAM spec just specifies name value pairs and HTTP format of upstream messaging from a set-top. It's really enabled us operationally to standardize everything so that when we onboard new applications, we needn't change our platform. It's really the goal of all of this, to build the platform so that new applications can be layered on with minimal impact. This was an important step in that in the past couple of years. Bandwidth limitations of the out-of-band, not on the DOCSIS pipe, but on the legacy pipe where the channel's smaller. The general, one important consideration is if the application is, would instigate synchronized messaging, like an RFI, or like something that's in a 30-second ad, and where if people opt in, they're all going to push the button within 2 or 3 seconds of each other because it's only offered for a few seconds. Then one of the constraints on our current legacy out-of-band is that we have the application developer code in a random delay on when that post goes upstream. So the EBIF format allows for that. And so we just allow the post to occur, but the app sends it to the user agent, and the user agent doesn't kick it out of the set-top for a random number between the delay you give it. I think what we've been using for the Canoe RFI app is 8 minutes. So within 8 minutes, the post will make the box.
Is that 200 byte posts upstream?
It is. The size of the post upstream, again, because of the small upstream pipe on the legacy, I think that's never been a problem. The upstream information has really never been that big. It's on the downstream. Of course, you can have much more. So, and it really depends on the usage of the app. I think our experience has been tens of kilobytes are okay, not a megabyte. I think in EBIF, tens of kilobytes gives you pretty good information for news, weather, sports, for example. That's not a problem. But it has to be vetted, so it is something to be tracked. Security at the bottom. Thank you. One important aspect is if a programmer, like Home Shopping, wants to track a set-top in a home, for example, wants to know if it's a repeat purchaser, or if maybe an app allows a user to set up to get weather, they want to have a default zip code or to get their weather. And so that when they bring up the app, it'll always give them that zip code's weather. So the way we've done that is simply use the set-top MAC address. That's private information. We don't want to give our MAC addresses out to third parties. We just obfuscate them, and then obfuscate them in a way that the third party knows that that set-top will always send that same obfuscated address, and that's worked fine. We've allowed, and the programmers have allowed, the set-tops to send name and address, name and phone information up the out-of-band. The low-end set-tops, I think anything but the device class 3, like our true two-way set-tops, really don't have the CPU horsepower to do encryption. So that's a limitation. So we've allowed things like name and phone number to be sent up, but nothing like credit card information, which would require HTTPS. HTTPS is supported on our true two-way set-tops, so that would be an option there. And then the bottom, thank you. The bottom line is simply about using any communication off of Comcast network is always encrypted, HTTPS or VPNs, and in the case of the Xfinity Remote app, where you're on your PC directing your TV to tune or something like that. Again, that's making sure that no one else is directing your TV to tune. It requires a full layer of security throughout that network with the communication to the PC. So just some guidelines about remote control keys. So our product people give us guidelines about what they want to occur. And roughly, what they've given us is that apps can use left, right, up, and down to navigate, or OK select to navigate. An exit button should remove the app. We want that to be standard behavior. If people don't want an app on their screen, hit exit, it suspends, it's off the screen. That's a standard operating procedure. Another important rule that the product people give us is that they want the last button to make sense. Just like if you're in our guide and you hit last, you sort of walk the stack of what you've done in the last couple of pages you're on in the guide. So we're having app developers respect the last button. So if you're an app developer, the bottom line is you may need to register your app to consume a few keys, the ones you need to navigate, and maybe a last key so that you can follow the rules for last. And those are some of the guidelines with key consumption. Any questions on that? Co-op one. Go to the bottom. And I'm going to make sure I didn't miss one. Go to the bottom. That's the first one. Yeah. You can hit F5. Just hit F5 and bring it in. Yeah. Now toggle down to the bottom. Okay. No, that was it. I'm sorry. Yeah. Sorry about that.
You mentioned several minute back off on upstream stuff. That is several minutes. So of course one of the big advances of internet-based, pure internet technologies has been this massive scaling of response service rate, B-sites and so on.
Mm-hmm.
Do you see that having how big an impact is that having on what you can do with interactive apps? Because it's quite a big limitation to say that's to back off for minutes. I can understand totally.
I think the product people have to understand that limitation. So the use cases that are supported on the legacy network, not on the True 2A or DOCSIS network, are constrained and by that.
It's the last 100 yards or so, 100 meters from the curb to your house. It's the link point in the weak. Yeah.
I mean, it's the philosophy I started with at the beginning was this is a bridge technology. Any of the overtop channels or even Java apps on our DOCSIS boxes, all are going to enable all this better functionality. This is what we're doing today for the next couple of years to support our customers. So.
I did see the slide that said you were planning for an average of about 200 kilobits, if I remember right, per second for the data channel, for the EISS.
The bound.
For bound data.
Yeah.
Do you have also limitations then on how much data that represents, or the size of the carousel, essentially 3 seconds, 5 seconds?
It was actually buried in that.
It might have been
in that big table.
Slide. Okay.
It was and you had the 3 classes of devices, and the low end ones. There was one of the boxes could only handle 100 kilobytes total of data.
Okay.
Regardless of the bit rate at which it was spun.
Okay.
But most of them were 500 kilobytes or 1 or 2 megabytes. The D2K was the only one that was limited to 100 kilobytes.
Right, I may not download all that information at the same time if it's things that I'll pick here or pick there. But is there like a 5-second carousel is the maximum, or a 10-second?
That's really
or it doesn't matter.
Because if the app lives in a program and you don't care if it comes up, if it takes 7 seconds to come up, then you can carousel it slower because the user tunes in and they don't know that it's coming up.
Okay.
But if it's in a 30-second ad,
then you got it.
Then you slow.
Can you speak to a little bit what one of the conversations this morning was about? How do you send EBIF-like applications to devices that are not connected to the central line?
Does that answer your question? No, I don't. I mean, I think that's a.
I mean, this is called the of tomorrow.
I know. This was the real tomorrow, and then that's the next year tomorrow. Yeah. No, I think I understand the goal, and I think I think we are really trying to unify our silos. And we've done a lot to the Xfinity remote and the caller ID to really merge our, get our video out onto the data silo, the PCs and smartphones and iPads. And so, philosophically, all I can say is that we want to get there. Exactly how.
Were you in the session this morning with the guy whose name is almost exactly like yours?
I wasn't. I was practicing my talk.
He was just saying, like, one of the methods would be to, instead of putting in a trigger, put in like a bookmark or an HTML flag, and then put the user agent in the cloud.
Steve the intro.
Yeah, right.
Yeah,
So, for a programmer, what do they have to do differently, or how far?
I mean, the couple of technologies I've seen, today, where the automatic content recognition can be used to synchronize your iPad to your TV, and a bookmark like that. So I mean, I would be conjecturing.
It's in the lab.
It's in the lab. Yeah.
Okay.
That is the tomorrow. I mean, that's a big. The interesting thing is that you may always, in terms of the second device, there are use cases where that's going to be great. There probably will always be a use case for the primary device, where you don't, advertisement, where you really want eyeballs and you don't want to rely on. So, I mean, we're looking in the future, but I think understanding that both are valuable is probably part of that.
In talking about tomorrow, in your estimation, how many years down the road will we not even be looking at Dev 1?
Oh, device class 1. When's the D2K going to go away?
Yeah.
A couple years, I don't know.
A couple of years?
I have no idea. People have been saying that for 10 years.
Is there a plan?
Yeah.
I think we are not, as people hand them back in, I don't believe we're giving them out.
I think there's plans for the party that we're going to have when they're all gone.
I don't really, I can't say anything more specific though. Thanks very much. Thank you.